This presentation is all about optimizing object storage in Ceph, the Rados Gateway. And one of the big challenges with the Rados Gateway is this existing problem around poor performance with erasure coding when you have small objects. And this is going to get better and technical. But I think that one of the other things that is a common need is to be able to put the data in your object store in the right place. And Amazon's got these different storage classes that are like Glacier and Standard, these different tiers of storage that have different performance characteristics to them, different durability characteristics. And with Ceph, you can do the same thing. You can create different storage classes in Ceph that have different levels of durability, different levels of performance, and then you can match the needs of those users. So if you got some users that are using the object store for something really high performance, like they're using it for some AI development, and then you've got some other users that are using it just for a long-term archive, you can kind of serve both needs by setting up some different storage classes. So what I'm going to go through is how we solve this problem with an intelligent data placement engine that we developed in Lua to embed into the Rados Gateway. I'm going to give you a little demo of Quantistore. We got some community edition licenses on a system, a 4-node, what we call a storage grid, and I'll show you how to set up everything, including the intelligent data placement rules. And at the end, I'm going to show you at the command line a quick screenshot of going and pushing a bunch of data in, having it go to the wrong place because the rules aren't set up, putting the rules in place, pushing data in, and now you'll see it go into the right storage class, and then fixing things up at the very end by taking the stuff that's in the wrong storage class and pushing it over. So everything at the end is in this storage class called storage IA. So yeah, let's see, everything on this we covered. So yeah, we're going to be able, with that intelligent data placement, we can help, users solve latency problems, ingest rate problems, all kinds of things, just by putting things into the right place. So kind of visually showing you what intelligent data placement looks like. You got these objects coming in from a bunch of clients that are going to get pushed into the Ceph cluster. And you might have two different storage classes, like this one's hybrid, where it's primarily platter with a little bit of flash storage, and this one's all flash. And what we want is to be able to push those objects in and make them go to the right place. And one of the neat things about the intelligent data placement engine is you get a checkbox that says, I want to force these rules. So even if the users got the bad idea that they're going to go and take up all of your flash storage with these big objects, which you don't want to have happen in your research environment, you can go and say, hey, I don't care if they're saying they want to put their terabyte images or whatever content in here. It's going to go and recategorize that. So you can have certain rules with the force flag on them to make sure users don't do the wrong thing. So how we solved it, I've touched on this a little bit, but basically embedded Lua scripting that goes right into the Rados Gateway. The Rados Gateway kind of has like a, when it receives a S3 put request to put an object in there, you get a chance to do a pre-request modification of the put. So you can say, hey, I see this put, that's going to the wrong place. I'm going to change the storage class setting on it, and then it goes into the gateway and actually then puts it where you want it to go. There's also a post request where after the request has been processed, like the object's been written, that you can modify things on the post side. We're just all focused on the pre side, where that pre-request comes in. That's where we need to change the storage class setting. And it's really just in Lua, you get this structure called requests, and there's a field that's storage class. So request.storage class, you can write just a few lines of Lua and set that to whatever you want. So you can take a look at the request, see, okay, is this match some pattern, like is it a PDF object or a certain file type or a certain size, and then just change that one field to what you want it to go do. So it's pretty easy to do some really basic Lua scripting. We've done something a bit more advanced here. We've got a whole rules engine and stuff. But yeah, it's such a great thing that Lua integration was done into the Rados Gateway, because it just opens up this whole world of ways that you can start categorizing data. The other part of how we solve this is, of course, leveraging having multiple pools. So we can have a pool that's standard, another one that's called standard IA. These names like standard and standard IA, they come right out of Amazon's S3. So Amazon has a bunch of storage classes, and we use those same names. You can make up your own storage class names, but you don't want to do that because all the software that's been written to be talking to the S3 protocol, if you use storage class names that is not used by Amazon, then the software will say, oh, I don't support this. And that goes for all kinds of software, whether it's Veeam, whether it's Veritas Net Backup, S3 CMD, all these utilities will basically fail if you don't use the naming conventions to make it really emulate Amazon. So in Quantistore, we literally give you a drop-down list to go pick one that's a good name so that you can avoid those kinds of problems. And then our Lua code, we got some example Lua code out on GitHub. So if you're looking on building some of your own code around that, there's a bunch of good examples where we put an early version of the auto tiering code out on GitHub. So we're going to use Quantistore Community Edition for the demo to kind of go set up a Ceph cluster and put the rules in. And then these links here are to some other articles that we wrote up and are on the Ceph.io blog. So the auto tiering, there's a part 1 and a part 2. There's really a 3-part to this, and what you're seeing today is kind of the 3rd part of this 3-part series. But for kind of more deep dive information on intelligent tiering with Rados Gateway, those are some great resources. So with that, I'm going to dive right into the demo of setting up Quantistore using a 4-node Quantistore grid. For those unfamiliar with Quantistore, we have this distributed control plane that we call a grid, and in this case, there's 4 servers in it. So we can take those 4 servers and turn them into a Ceph cluster. If we had more servers in the grid, like 10, then we could divide that up into 2 clusters of 5 or 1 of 3 and 1 of 7. But this is what the user interface looks like after you've done the bare metal install of the operating system onto a server. So all the setup we're going to do is over here on the scale out storage configuration tab. That's where all the Ceph cluster setup is at. And I also wanted to point out in the upper right hand corner, this getting started button gives you all these workflows. So it's like a sing-along bouncing ball to go set up an object storage pool. You just go and click on that, and it gives you a step-by-step guide, and you can just click on the button, and it will bring up like cluster creation and all that. I'm not really going to be pressing the buttons here with the getting started. I'm just going to go to the right spots in the web UI. But if you want kind of the quick and easy recipe of how to go set up various things, that's a great place to go find it. And it's just here in this upper right-hand corner. All right, so the first step in creating a Ceph cluster is to select the nodes that you want to use for the Ceph cluster. I'm just going to select all the nodes, and then I'm going to use the same network interface on the front end and the back end. And then once you click OK, it builds the Ceph cluster. I took screenshots because some of these steps take a couple of minutes, and this lets us kind of fast forward and make better use of time. But once the cluster is created, it's already deployed the monitors across those nodes. And you can see the monitors are in the normal status, so we're ready to go on to the next step, which is adding all the OSDs into the cluster. So this is done in this next section, which is the data and journal devices section. And we're going to just click this auto config button, and it's going to go and automatically figure out which are my hard drives and which are my SSDs and select them over to the other side. For this demo, I was using virtual machines, so that's why the device sizes are small. But normally these would be like like 20 terabyte drives and 7 terabyte SSDs. So now that I've clicked and told it to go set up all our OSDs, these are all the OSDs, they're all set up. These things that are called journal groups are basically mirror pairs of SSD storage that provide the write log, the WAL, and the MDB offload. So all of that setup is done automatically for you. So now that we've created the cluster, added some media in there, we're ready to start setting up the object storage. And we're going to tell it that we're going to use US East 1. And again, this is also where we're trying to emulate Amazon. One of the defaults in Ceph is to call the your region, your zone name default, which is actually a bad idea. You want it to really look like Amazon. You want it to be called US East 1 or US West 1, and there's a whole bunch of these region names. Those are all in this drop-down box, so you can just pick one that's in whatever part of the world you're deploying your cluster in, and then you can make it emulate what Amazon's S3 looks like in that region. And the first pool that we're going to create is a replica 3, and that's intentional. We want the first pool to be replica 3 and tied to the name standard. And that's because whenever you create an object in the object store, even if we decide to tell it, this object should go over to the erasure coded side, it makes a tiny little piece of metadata, kind of almost a 0-byte header or 4K header piece that ends up going into the standard storage class. And so if that's Flash, the little 4K objects are in the right location. So we always start by making that replica 3. And then once you click that, your object storage is now set up from a pool perspective. We've got to go and turn on the Rados gateway. So we've got the object pools. Now we've got to go and make it so that you can start writing in and talking the S3 protocol. And that's done through this next dialog where you click deploy object storage gateways. And we're going to deploy them on every node of the cluster. And that's also really important. It used to be back in the day that you would just run the Rados gateway on a couple of nodes, like 2 or 3 nodes. It's just a bad idea. You want the Rados gateway deployed everywhere because your performance is going to linearly scale with more and more gateways. And we've tested that a bunch of times, and it's really amazing just seeing that performance climb and climb. So if you've got OSD nodes, well, they're not just OSD nodes. Use those for your Rados gateways at the same time. You're going to get a lot of benefit out of that versus kind of old school trying to dedicate some nodes just to run that object storage gateway. On the advanced settings tab are the load balancer. When we deploy these Rados gateways, it's also deploying the load balancers for us at the same time. So you've got a nice mesh network of all the load balancing already set up for us. And so I went back to this tab here for the the scale out storage clusters so you can see the breakdown of all the nodes and all the services that are running on there. So it's not just the monitors, but we've got the Rados gateways and the load balancers running across all the different nodes. The next version is going to have the ability to customize those Rados gateways. So you can say, hey, I want this gateway to just do garbage collection. I want this Rados gateway to just be able to do notifications and things like that. So you'll be able to do further customization of the gateways. So now we've got the gateways deployed, our object storage is set up. We can now go and add a second storage class because, we're going to want some of it going to our replica 3, some of it going to our erasure coding. We haven't yet set up that erasure coded pool, and we're going to call this storage, we're going to use the storage class name of standard IA, which is another one that's available at Amazon. IA means infrequently accessed, and that's a good fit for stuff that we're going to use on a large erasure code stripe. For the demo here today, I only have 4 nodes, so I'm going to use a 2+2 erasure coding. And you just click OK, and it's going to go create that extra pool for us. So you see there's a second pool now called storage IA data, and it's associated with that storage class. So we've set up the whole cluster. We've set up the object store, the Rados gateways. Now we can start putting in our rules. And there's really one rule that's the most important today, is you want those small objects to be on the replicated flash storage. You want the big things to go out there to the erasure coded. And so the thing that we do on literally every object storage deployment we do today is this one rule here, which is anything bigger than 32 kilobytes, I want that to go into storage class standard IA. So you go and specify your rule over here on the far left side, what storage class you want it to go into, and what rule, like greater than 32K or greater than 1 meg, and click add, and you can go and add these rules. You can also change the order of the rules in which you want them to be executed. So sometimes you'll say, I want it to go and execute this rule first because I want it to go categorize the standard IA. Maybe some other rules would overlap, but you get to control which order they get executed in or evaluated in. And one other thing that we added in this rules engine is this overflow rules capability, because what if you've got a particular storage class that's filling up, or a device type like your NVMe tier is starting to fill up? You can say, you know what, when I hit 80% on my NVMe tier, just start putting all the stuff that would have gone to that pool over here to my triple replicated HDD. And that way you can eliminate, being on vacation and then having your cluster fill up. So there's some nice protections with these overflow rules so you can put in standard rules, and the overflow rules only kick in when a particular capacity threshold has been reached, and then they become active as well. So that's the rules engine and how to go configure them. You just click OK, and it goes and applies that to all the Rados gateways across all the systems. And you're basically now ready to push data in. So before we can push data in, we have to create a user. So this is just creating an object storage user inside the Rados gateway. And then we need to grab the keys out of there so that we can use those keys to run various commands, using S5CMD and other utilities. So here I'm going to copy those keys to the clipboard. And now I've got the whole cluster set up. Now before we can start talking to it, we need to know what the IP address is for talking to the cluster. And basically, you can go to every node directly over like HTTP and talk directly to the Rados gateway. But we really want to go in through a secure HTTPS connection. And so we run HA proxy in that mesh load balancer across all the nodes. And you'll notice an asterisk here. That means that you can go into the object store through any IP address that's on any of the boxes. And that's very handy, because if you're going to go and set up a bunch of VLANs and then map different departments in over different VLANs, they're going to all want access to that object store. And you don't have to worry about whether or not they're on the network that is using the Ceph front end, back end. None of that matters. They're all going to come in through HA proxy, and that can come in through any of those interfaces that they've set up. So that's kind of the key part of that's the whole QuantaStore setup side. It's ready to push data in. I made a bucket just called test bucket here, and let me go back. And this is kind of the end of where the rubber meets the road with the demo. This part at the top, I put like a bunch of objects in. I think it was like a couple of gigs worth of objects before it got to this screen. And we have this command line utility you can see there called QSS3util, and there's an analyze buckets command that we're running here, and it tells us where all the objects are at and how much space they're taking. And so that first time I put objects in, I didn't have any rules in place, so everything just goes into what's called the standard storage class. And now you can see the category medium 1024K, it's telling me what size were those objects that I put in there. And so you can go in and analyze your buckets and kind of find out who's put big things into the wrong buckets or the wrong storage class within a bucket. So then we put the rule in place. That's that step there. And then we create some more objects at this step. And now you can see with the rule in place, the next batch, I now have 400 objects. I created 2 and then created another 200. That second 200 all went into the right place. It went into standard IA. So we've got all the stuff going into the erasure-coded pool. But we're kind of stuck, right? We got half the data in the right spot, which was put in after the rule is in place, and half the data in the wrong spot. Say some researcher was putting data in before the right rules were in place. So we need to move that data that's in standard over to standard IA. We want to move it out of the replica pool and into the erasure-coded pool. So we built this other utility or command, which is move objects. And you just tell it, hey, I want everything that is a minimum size of 500K, just move that over to standard IA for me. You click OK, and it goes and analyzes the bucket and then recategorizes all that data that's in the wrong spot to put it in the right spot. And then it prints out a report. And you can see now everything in the report says standard IA on it, whereas here it was mixed up. So, with half the data in standard and half the data in standard IA. So that's the whole process. If you're diving into writing your own Lua scripts, as mentioned earlier, there's some great resources that we have on GitHub that was on that earlier slide. These are also some links that'll take you there as well that are on the blog for Ceph.io. And then to try QuantaStore Community Edition, you can just get that from our downloads page. It's free. as in free beer, and you can take it up to like 4 nodes and 400 terabytes. All right. Thanks. Cool.